Hello everybody, this is Jim Duvall. I'm president of CAView Companies, and today I'd like to go through something that I get asked all the time, and that's how do we actually use the application from beginning to end as though you were actually pre-flight planning an actual flight. So without actually using a transcript of any kind, I'll just go through some of the major points and walk you through how I would actually use the application. First, you'll notice that there are two sets of buttons, the blue buttons and the black buttons. The blue buttons are those that you're going to actually use on a daily basis and are the primary buttons, and the black buttons are the secondary or resource type, administrative type buttons. So beginning at the very top, you'll notice there's a button there that says a tail number on it, and this is just representing that this is the airplane that's presently loaded in the system. If you would like to change this aircraft, you just simply touch on the button, and you'll notice that a screen comes up with your entire fleet showing there by tail number and aircraft type. One of the things that you'll notice is that we actually support all different types of manufacturer aircraft, and they can all coexist at the same time on the application. And this is actually a feature that is often overlooked in that you can use the same application for any type of aircraft. So let's just say that I want to select the Falcon 50. I'll go ahead and select that on the screen. That automatically loads the airplane, and at the same time it loads the performance for the Falcon 50. It loads the weight and balance specific to this tail number. Okay, the next button down is called New Flight, and as the name implies, this is the button you'd go to if you're doing pre-flight planning for a new flight. What happens in the background when you press this button is that all the parameters that you've previously entered, such as temperatures or wind direction, the airports of departure or arrival, weight and balance information, your fuel load, all that type of information is reset to 0 so that it assures you that you're starting with a fresh slate. There is one exception to what is zeroed out. If you select the New Flight button, you'll notice that a alert button comes up with the option to save the passengers or to clear all. If you were on a multiple leg flight and you had several passengers already loaded into your weight and balance, you would not want to have to re-enter those on each leg. So we give you the option to save the passengers, and it just makes the whole process go a little easier. If I go ahead and save passenger, I'll show you how this works. You'll notice that the weight and balance system enters at the point of fuel load. You'll notice at the top there's a tab bar. They have a number of icons. The one that's lit up is called fuel, so we're on the fuel page. Now, this is not to imply that you can't go back and change your passengers. Let's say one passenger gets off or another one comes on board at a particular point. If you select the passenger icon at the top, you'll notice that all your passengers are preserved from a previous flight. Let's say a female passenger boards the flight. You'd click on the F button at the bottom of the page. You'll notice that that's highlighted now. And now you just select the seat that you want to place her in. And it basically is just that fast. If you want to remove a person from the flight, you click on the E button and then select that seat again, and you remove that person from their seating assignment. The C represents child, and the pounds is where you enter an actual weight. So if we go ahead and click on pounds, you'll notice that a screen comes up. You can enter an actual weight, let's say 190 pounds, and put that person into that particular seat. If we go back to the fuel page again by clicking on the fuel button, you'll notice that we can enter weight for the total fuel load. You can actually have the 3 tanks listed there, and I'm going to enter essentially a full fuel load. Now you'll notice at the bottom you have en route fuel, a reserve fuel, and a taxi burn. The reserve fuel is the amount of fuel you want to have upon landing. If I put in a number here that's obviously going to conflict with that, I'm going to say I'm going to burn 14,700 pounds. If I have a taxi burn of 300 and a reserve fuel of 1,000, that's going to be a problem. So I'm going to go ahead and click on Done. I'll go ahead and select the Manifest page, the last tab over on the right, and you'll notice that you get your weight and balance tree with the number of passengers up there in the 4th row down. You see the passenger count is listed there for you. But you got a couple entries that are in red. And we always tell pilots you need to get the red out. You're in the CG envelope. If I pull up the envelope graph here, you'll notice that your CG is actually fine as far as being within limits. The green line represents fuel burn-off. But we need to fix that reserve problem. So we're going to go back to the fuel tab. We're going to change our fuel burn down to something a little more reasonable here. And we'll click Done. And then we'll go back to the manifest page, and you'll see it all turns black. The center of gravity values can be displayed as either in inches or in percent of Mach, and I'll show you at the end of the presentation how you set that in the default section. Now down at the bottom lower hand left corner, you'll notice there's an email weight and balance button. You can send this weight and balance by email or just save it in your mail client, pull up later. And you can enter things like pilot names and route information, that type of thing, at the time of sending the email. But up in the upper right-hand corner, I'm going to select Accept. That'll take us right into the next step of our pre-flight planning, which is the performance section. Okay, the performance section has 5 pages associated with it, and they're represented by the icons at the bottom of the screen. You'll notice the one that's highlighted is called Departure. The one next to that is Obstacles. The third, the middle one, is the Arrival Airport. And then you have settings such as bleed air, on or off, or anti-skid, or system settings. And then you have the toll card itself, which is the last button. You can navigate to any of these sections in any order that you wish by using the tab bar at the bottom. Or you can use the blue button at the upper right-hand corner. It's called Next. And this represents more of like a step-by-step procedure like you'd see in a tax application or something where they walk you through the entire process step by step. You can also click on the upper left-hand button, which is called Main, and that takes you back to the main screen. If you want to return to the performance section, just click on the performance button, not New Flight because that'll zero out all of your data, but just click on Performance and that'll bring you back. The departure screen and the arrival screen both have a Select Airport button. And once you select that button, you'll see a screen that has a place for an identifier. You can set your own airport there as your default airport if you wish, or you can put in the 3-letter identifier. Go ahead and put in Aspen here. And you'll notice that at the bottom of the page, the weather automatically comes up if you're connected to an internet connection. If an internet connection is not available, you will still see the runway information. Now in this particular case, we're going to go ahead and select runway 33 and hit Accept in the upper right-hand corner. You notice that pre-fills in the entire page for the departure screen. You can override any of these values that you wish. For instance, if I select outside air temperature, if I just put the cursor in that field, it zeroes it out, and you can go ahead and put in whatever value you wish. At the bottom of the screen, you'll notice about halfway down, you'll see a Runway Conditions button. And depending on the manufacturer, you'll see a whole host of different runway conditions here. You can see standing water, slush, snow, compact snow, so on and so forth. It just depends on what the manufacturer provides. And to select that, you can just select the button from the control. We'll go ahead and put dry runway back in there. We're all done with the departure screen, so we'll move on to obstacles. Again, you can get there from either pressing the next button in the upper right-hand corner or the obstacle button in the lower tab. Now the obstacle screen can really be filled out in about 30 seconds, but we're going to hang out here for a bit because I wanted you to see exactly where I get the information from on the departure plates, and also clear up some misconceptions that have been floating around on the internet in some of the performance videos. Before I get too far into that though, I want you to notice at the top of the screen you have a button there that says DP ODP SID. And if you toggle that button, you will find that you have the opportunity to do a known obstacle calculations as well by putting in a height of an obstacle and a distance from the end of the runway. But we're going to focus our attentions on the SID or obstacle clearance associated with the departure procedure. Now the top 2 boxes are called required climb and up to altitude. Now where do we get those from? Well, you'll need your departure procedure, either the graphical or the textual description of that. We provide for you NOS charts down at the lower right-hand corner. You'll notice you have a button down there where you can go online and get the departure procedure that you need. Now, I'm going to go ahead and bring over a departure procedure for Aspen, the LINS 8 departure. And in the takeoff minimum section at the top of the chart, you'll notice that you have for runway 33, 400-foot ceiling with 1 mile visibility with a minimum of 465 feet per nautical mile to 10,000 feet. Those are the 2 numbers we need to enter the top 2 fields on our program. So let's go ahead and do that. You enter the numbers exactly as they appear off the chart. You don't have to make any calculations. We do all that for you behind the scene. Now the next entry is called turn crossing height. You may or may not make this entry depending on the departure procedure. Let me drag the Aspen departure back in here again. And you'll notice down here is a entry here for a turn at 9,100 feet MSL. That entry needs to be entered into our calculation, so we will tell you when to make the turn. If you wait to get to 9,100 feet MSL with one engine and up, you may be way out here somewhere where the yellow ball is. So we're going to recalculate where that turn is for you in an MSL temperature corrected number so that you can make that turn. So the number you're going to enter into the application is 9,100 feet. So let's do that. Now the next two toggles, you'll have banks greater than 15 degrees. You'll toggle that on yes or no. Most of the time it's going to be at no. And the type of standard you're going to use for your departure, it's either going to be ICAO or TERPS. In the United States, we have a different set of rules for calculating departure procedures than essentially the rest of the world that uses the PAN-OPS system. So if you're inside the United States, particularly if you're in the mountainous terrain in the United States, you're going to use TERPS. Otherwise, anywhere else in the world, you'll select ICAO. I'll refer you to the other videos that we've done for a more in-depth explanation of that. The last toggle there is close-in obstacles, and it's a yes or no question. Over the last several months, close-in obstacles has gained quite a bit of attention. In particular, there are a number of videos that have been produced online that actually give a great deal of false information about close-in obstacles. One of my customers who had watched one of those videos came back to me quite concerned. I asked him if he were able to meet the entire SID with one engine in op, if he would run the risk of hitting any obstacles. And he answered yes, that departure procedures were only for all engines operating. Now I don't know how a departure procedure would know if you have all engines operating or not, but I did go back and look at the video that he was referring to, and sure enough, they did in fact give the impression that with the new close-in obstacle clearances under the new TERP rules, that you could in fact run into obstacles. So let me try to clarify exactly what is going on. Let me move in a whiteboard here where I can draw. Let's say we have a runway represented by this black line, and we have some obstacles here at the departure end of the runway. Now, about 10 years ago, TERPS and PAN-OPS had essentially the same criteria for departure procedures. And departure procedures at that point in time all began at 35 feet above the end of the runway. So you would have a departure procedure that looked something like that. And beneath that departure procedure, you would have a net obstacle clearance surface which provided all terrain and all obstacle clearance. In addition to this, you would have the performance of the aircraft at 35 feet. Because there was a limitation on the height of obstacles that were close in, they all fell well below the obstacle clearance surface of the departure procedure. So think of it this way. Under the old rules and under the current rules of ICAO, both the aircraft performance and the obstacle identification surface of the TERPS procedure both gave you obstacle clearance on a departure procedure. For some reason, however, TERPS changed in about 2004, where the departure procedure now didn't start at 35 feet, but now starts at the runway surface. Thus, while the new TERPS procedures do not provide obstacle clearance close in, the aircraft performance continues to provide close-in obstacle clearance based on the reference height of 35 feet of all aircraft flight manual performance. Now what it does not provide is Part 135, Part 121, and Part 91K obstacle clearance. Now if you recall, I said that these close-in obstacles could not be any taller than 35 feet above the 40-to-1 obstacle plane. That would be represented by this gray line here, parallel to the red line. So any obstacle that falls within that zone would have to be identified under the new criteria. But not all of these obstacles would be a factor in Part 135 clearance, which would be represented by this yellow line, which is parallel to the net takeoff flight path profile of the aircraft performance data. Notice that the yellow line, which represents the Part 135 obstacle clearance requirement, crosses the gray line, And the point at which it crosses the gray line depends largely on the steepness of the climb gradient. The higher or the steeper the climb gradient, the closer that point where they cross is to the end of the runway. So in this example, the closest in obstacle is a factor for 135 clearance. It needs to be dealt with. The second obstacle out is potentially a factor because it is within the range of obstacles that are a factor, and the third obstacle is just not a factor. So the question then is, how do we determine what that distance is at which point the yellow line crosses the gray line? So if we return to our application, adjacent to the button called Close-in Obstacles, you'll notice a description of the zone where close-in obstacles could potentially be a factor. So in this example, with a 465 foot per nautical mile climb gradient, any close-in obstacle within 2,110 feet of the end of the runway and within 300 feet laterally of the center line would be considered a close-in obstacle that needs to be factored into the calculation. If we find that an obstacle does fall within that zone, we just simply toggle yes for close-in obstacles. So let's see if any obstacles actually are a factor for the Aspen departure. Move my departure plate back in, and you will notice down in the section called Takeoff Obstacle Notes that for runway 33 you have multiple trees beginning at 35 feet from the departure on the runway. That's certainly within 2,100 feet, but it's 386 feet off the center line, so that's not a factor. The second group, the multiple trees and bushes, terrain beginning 4 feet from the end of the runway, again within the 2,100 foot envelope, but 400 feet off the center line, again not a factor. The last group of obstacles that are regarded as close-in obstacles are, again, multiple trees and bushes, terrain beginning 3,484 feet from the end of the runway. This is beyond the 2,110 feet envelope that we calculated, so those are not a factor either. Returning to our application, we see that none of the close-in obstacles that are reported are a factor, so we'll leave close-in obstacles toggled to no. If close-in obstacles had been present, we toggled it to yes. Essentially, all that we do for the calculation is we raise the reference height of the aircraft from 35 feet to 70 feet at the end of the runway. By doing this, we would clear all known close-in obstacles by Part 135 clearance standards. Clicking on Done, we activate our next button and we'll go on to the arrival airport. Here, like the departure airport, we select airport. We can type in our airport that we're intending to land at. We'll just say Burbank. Here's the weather, and according to the winds, we'll be landing to the south. And that fills in that criteria for us very nicely. And again, we can select the runway condition, and we continue on to the next screen. The System and Settings page will differ dramatically depending on the type of aircraft that you have, but some of the features that are common to all aircraft is you'll have a flight phase and a flap setting button and a subsystem button that deals with ice on or ice off. Obviously, the flight phase you can toggle between takeoff, en route, and landing, and the flap setting automatically changes when you do that. We're going to deal with a takeoff calculation here. And you'll notice you have DP outside air temperature and DP pressure altitude. Those are values that we calculate for the departure procedure. And then you have your gross weight, which was carried over from your weight and balance, and your outside air temperature. All that's left is to push the next button to calculate our total card. And you'll notice that we get a number of entries that are in red that say headwind. Did this on purpose so you could see that when you do exceed your limits of the charts, they will be identified in the output. So what we'll do is we'll go back to our departure screen by clicking on the departure button at the bottom of the screen. You'll notice that we had a 14 knot tailwind. I'm going to change that to a 14 knot headwind. 14 knots would exceed the tailwind component of that aircraft. And then we'll go ahead and run the toll card again. And again, you see we get some red numbers, but nothing that says headwind in it. The red numbers here represent, for instance, takeoff distance is greater than the runway length that we entered. And the max weight field is in red because it is less than the pounds that we entered on the previous screen for our takeoff weight. And then all the V speed numbers are in red because they are recalculated based upon the lowest weight. So in order to fix this, we need to go back to our told card and move our weight down to 38,000 pounds. Click on Done, click on Next. And you'll notice all the entries are in black, which means you're good to go. You'll notice a couple of entries. Turn to heading at 8,254 feet. This is the altitude at which you'll begin your turn to the 273-degree heading. If you recall, in the Aspen departure plate, we had this 9,100-foot crossing restriction for the actual departure, but when you have a single engine out and you're dealing with the climb gradients correspond with engine out procedure, you're going to make your turn at 8,254 feet. This is a temperature corrected altitude, so you can read it right off your altimeter. That's when you begin your turn. Also notice that you have a mandatory level off at 9,102 feet MSL, again temperature corrected, which represents the upper limit of your second segment climb charts, and then you have all the remaining V speeds that you'll need for takeoff and climb. The toll card can be emailed just as the weight and balance could be. The button is up in the upper right hand corner. Remember to return to your weight and balance to adjust your fuel load to meet the 38,000 pound departure weight. And also we can go back to our system settings page, adjust our flight phase to landing, and now the values here will be reflective of the Burbank Airport, and we can go ahead and do our landing calculations as well. Remember that you do not require an internet connection, so these calculations can be done in the cockpit. Just a few notes about the other buttons on the application. We're going to return to our main screen, and diverting your attention down at the bottom under Setup, you will see that there are a number of toggles here. You can show the CG as a percent of Mach versus inches. You can show weight in kilograms versus pounds, and you can also start the new flight in the toll card section versus the weight and balance section, which we demonstrated today. You can also change the BEW and the BEW CG of the aircraft on the fly in case there are any last-minute changes that need to be made. This does not update any of the other devices that you have, just updates this one particular device. If I return to the main page again, there are 3 other buttons down at the bottom. Weather is pretty self-explanatory. FBO is an online service discussing the services that are available at different FBOs. And the library button has on the left-hand side a number of built-in links to online services such as icing levels and the National Airspace Status Report. On the right-hand side, you can build your own online links in the top 6 buttons there. And the bottom button is called Documents. You can develop a table of contents and a set of PDFs that you can build into the system. In this particular case, I have a FAA letter of agreement. Well, that pretty much is the whole process of going through the application. If you have any questions, feel free to give me a call or send me an email. I hope you enjoyed the presentation. So before we sign off, I'd just like to show you a couple of changes that have been made to the program since build 3.4, I believe, and some of the changes that Apple introduced with their new iOS. You'll see quite plainly here that the controls have all taken on a more two-dimensional design to them, and the three-dimensional shapes have pretty much been removed across the board from Apple. And that has cleaned up the screens considerably, and you'll also notice that we took the black buttons that were at the bottom of the screen in prior versions and combined many of them under just 2 buttons now, Setup and Resources. If you click on Resources, you'll notice that the features are still there. The holdover timetables, the fuel tankering, and the document reader, among other features, they're all shown here as different icons on this particular screen. So that kind of declutters the main screen a bit. In our cases, as far as performance is concerned, there's one feature that I want to show you called Pcast. If you go to the performance page and you go all the way over to settings, you'll notice we have a calculation here based on 15 degrees Celsius. And if you click on results, you'll notice you get the typical page with the red output. So this is a good example of where Pcast would be in use. And you'll notice down in the lower right-hand corner a thermometer icon. And if you go ahead and click on that, what you'll see is that the calculations are done multiple times, holding all the parameters constant except for temperature. and we vary temperature from 50 degrees Celsius down by 2 degrees Celsius increments down to like 0 degrees Celsius. And what you'll notice here is you get red, green, and yellow icons. The red icon obviously means that you are beyond your limits for that category. The green means you're within limits. And the green-yellow icon means that you're within limits, but you're within 500 pounds or 500 feet of that particular parameter. Now, in this particular case, you'll notice that the first green icon within the takeoff distance column, is 10 degrees Celsius, which is 5 degrees cooler than what you are presently encountering. So this is a good example where you're going to be reducing weight. But how would weight vary for this particular calculation? Well, if you go up in the upper right-hand corner, you'll see a button called Toggle. Now here, if you click on that, what we'll see is what you'll have now is we'll hold temperature constant and we'll vary the weight by increments from the max weight of the airplane down to the empty weight of the aircraft. So that's how you use Pcast. You can do the calculations based both on holding the temperature constant or holding the weight constant and varying the temperature.